Alright, so today we're going to do dividing polynomials. And we're going to use long division. Tomorrow, we're going to use synthetic division, which is a very, very strange way of doing it. It's kind of like Kramer's rule. It's out there, okay? But today, we're going to use long division. So let's first talk about the thing you already know. Like numbers, if you're looking at your homework right now, what happens is 1 through like 4, you don't even need long division for. Okay, but you get so used to using long division, you'll use it on those also, but it's not necessary. Okay, numbers 1 through 4 are going to work just regular. When you divide, so dividing a polynomial. Okay, in other words, it's got many terms, by a monomial. You don't need long division, okay? So for example, for number 1, it said 15x to the 5th power plus 10x cubed minus 5x squared divided by 5x squared. And here's a common misconception kids tend to do. Okay, you don't need to write this to show and talk to you about it. For example, you might have 8x squared plus 3 divided by 2. Sometimes kids make a mistake and think that since this can simplify, they'll write the answer as 4x squared plus 3. That's false. Okay, you have to divide the 2 into both. You could write it as 4x squared plus 3 halves. Okay, but the 2 goes with both sides, not just with one. Okay, you have to be careful of that. Now, knowing that, let's solve this problem by the same method. In other words, you're going to look at each one, okay, and divide, or simplify, in other words. So if you take 15 divided by 5, you're going to get 3. And then x to the 5th over x squared is x cubed. Now move to the next one. 10 divided by 5 is 2, so plus 2. And then a cubed over a squared is just an x. And lastly, the last set, those are exactly the same. So what's it going to give me? A negative 1. Excellent. Okay, number 2. It's 16a to the 8th minus 4a to the 6th power plus 8a cubed minus 3a all over 2a cubed. The same concept. You're going to apply it to each one. In other words, you're simplifying. It's every single term divided by 2a cubed. Okay. When you take a look, then 16 divided by 2 is 8, and then an 8 with a 3. You subtract them, right? 8 minus 3 is 5, so a to the 5th. 4 divided by 2 is 2, and then 6 minus 3 is 3, so minus 2a cubed. 8 divided by 4, I'm sorry, 8 divided by 2 is 4, and then the a's cancel. Okay, the last one's the weird one. It's not pretty, correct? So maybe think in your head over here for a second. This is what I have. I have the negative 3a and then 2a cubed. That's what I've got. The 3 and the 2 don't really do anything. So let's leave them there. So minus 3 over 2. Let's look at our a's now. This a is going to cancel, leaving me with how many a's in the bottom? 2. So it's 3 over 2a squared. That's a monomial, right? That's nothing new. You guys have divided like that for a long time. The next thing we're going to do, though, is instead of dividing by a monomial, in other words, just a 2a cubed or 5x squared, we're going to divide by a binomial. We're going to do it in two ways. Today we're going to do long division, which is very inherent because it's just like dividing. We've divided forever. Okay. Tomorrow is synthetic division. That's kind of the weird way to do it. Kind of like Kramer's rule, a little bit out there. Tomorrow's a little bit out there, but easy. Okay. So you have to decide which one you like better. Right. Let's look at dividing long division. We're going to dividing a polynomial by a binomial. And there are times where you have to use this, and we'll talk more about that tomorrow. Here's your first example. If I give you 15x squared plus 8x minus 12 divided by 3x plus 1. Okay, I'm going to just kind of over here smallly remind you about how to divide. Okay, so look, this is kind of cheesy, but just walk through it with me. Pretend like you need this. We're going to talk about it in a second. So if I take 5 and divide by, I don't know, 157, we'll do that. Okay. Well, I don't want it to work perfectly, so let's make this an 8. All right, do y'all remember how to divide? Okay, what did we say? It just sounds silly, but you'll need it in a second. So does 5 fit into 1? No. Does 5 fit into 15? Right? Okay, and you would put a 3, and then you would say 3 times 5 is 15, right? Now this next step is important. What would we do in this spot right here? Add or subtract? Okay, subtract. Then, after we subtract, what would we do next? Bring down the 7. And don't you feel like a little kid again? Alright, so now then you would say, does 5 fit into 7?
Yeah.
Right, how many times? And then, to get our number, we would say 1 times 5, and we subtract, right? And then what do we do next? Bring down the 8, and 5 is in the 28, 5 times, which is 25. How many's left over? 3. Okay, so, what do we do now? Lots of different options. Okay, when you're really little, at the very beginning, you would put R3, because you had no clue what it meant, okay? Then when you got a little smarter, okay, you would say, you would put a decimal and add a 0, okay? And you can do that. You can put a decimal, or you can look at it and say, this is 3 out of how many? 3 out of 5, which as a decimal would be point what? 0.6. So I could have added decimal and added 0, and I would have gotten 6. Okay, or I would just know 3/5 is 0.6. Just depends on how pretty the problem is. Okay, that's our division algorithm. Well, it's not going to change for today. So then we're going to divide, but just a little more complex. You really do need division again in algebra too. Who would have thought, right? So we're dividing this time instead of by 5. We're going to divide by 3x plus 1. And inside our house, right? Okay, is this big polynomial. The first step is, if you'll notice, we kept getting rid of numbers slowly and slowly and slowly, right? And it finally left us with just one number. That's kind of what's going to go on here, right? You are going to look at 3x and 15x. You just look at the first term of both. Now, here's the problem. Go back to our division problem. Did 5 fit into 1? No, so we didn't put anything there. Well, this whole binomial, even if I just multiplied it by 1, how many terms am I still going to get? Well, if I multiply this whole thing by 1, I'd get the same thing. 2 terms. So 2 terms aren't going to fit into 1. So we're not going to be able to do this. We're not going to put a number in that spot. But how many times does 3x fit into 15x squared? What do I need to make it perfect? 5 and an x. So you're going to put your 5x up here. And just like our algorithm before, look at our division problem. We did 3 times 5 was 15. Okay, you do the same thing. You're going to say, all right, except we have a binomial, so we're going to multiply by 2 things. So 5x times 3x is 15x squared. And then 5x times 1 is 5x. What did we do next? Did we add or did we subtract? We subtracted, so watch. Put a minus and you're subtracting both. Every single time, the first term, if you did it correct, they will be exactly the same because we need them to cancel. We're whittling away at them. We just want to get them, we want to cancel them one by one. So now 15 minus 15 is gone. Watch your signs. 8 minus 5 would be 3x. What did we do next? We brought down the, this time it's going to be a what? A negative 12. And again, you're going to look at the first of this and the first of what's left. 3x into 3x. What do I need? Does it go in perfectly?
Yeah.
Yeah, so what number do I need to put up there then? 1, so plus 1. Do I just multiply it by the 3x? No, you multiply it by both. If you need to draw yourself an arrow, you can. Both spots. So you're going to have 3x and a 1. You subtract them. So 3x minus 3x, if you did it right, they will cancel. Watch your signs now. Negative 12 minus another one would be negative 13. Go back and look at our simple baby problem over here. When we had a 3 left over, what did we do with it? We put it over what? 5. So in here, we're going to take this 13 and put it over the whole thing. Good. So minus 13 with 3x plus 1. So when you write your answer, it'll be 5x plus 1 minus 13 over 3x plus 1. Exact same division algorithm with just some really strange looking numbers. Okay, let's go to number 2. Two x cubed minus 5x squared plus 22x plus 51. 2x plus 3 to the negative 1 power. What's going on here? What are we doing? What does a negative 1 mean? What's it? Where does it belong? What does a negative exponent tell us? This is Friday's lesson.
Fraction.
It belongs where? It belongs in the denominator. Make yourself a little note if you didn't know that. Put 2x plus 3 in the denominator. If you've forgotten, that's what it does, remember? So now we actually have this whole thing divided by 2x plus 3. That's what we really have. So write your problem. And we only look at the beginning every time. We're going to try to chip away at this huge polynomial by canceling one term at a time. Okay? So the first term we're going to look at is a 2x and a 2x cubed. What do I need to multiply 2x by to get 2x cubed? An x. Okay, nothing goes here, so x. Remember, you have to multiply both of them. So 2x times x is 2x cubed, and then 3 times x is positive 3x. Oh, I'm sorry, we need x squared. Thank you. Sorry. We need an x squared. I apologize. So now we're going to subtract. These cancel. Watch your signs. A negative 5 minus 3 is actually a negative 8. X squared. Bring down what?
2x.
Bring down your next term. Stop and think. We're trying to whittle it away as we go. So we're going to take the 2x, and what are we going to whittle it with, or just try to cancel? The 8x squared. You try to see if you can come up with a number that goes there. What number goes there? What'd you pick? A negative 4x. They have to be exactly the same. 4x won't cancel. They need to be a negative 4. So negative 4x gives you negative 8x squared minus 12x. You're going to subtract them. Negative 8 plus 8 is what that turns into. So it goes away. Negative 22 plus 12 is positive 34x. Show me where.
22x.
22 minus a negative 12. You're subtracting, be careful. Bring down your 51. I've got a 2 and a 34x. What am I going to use? A 17. Excellent. 17 times 2 is 34x. They match, so you know they'll cancel. 17 times 3 is 51. This time you got nothing left over, correct? So you can just write your answer. X squared minus 4x plus 17. Ready? Okay. There's 5. We're going to do 5. 4c cubed plus 4c squared plus 5c minus 3 divided by 2c plus 1. Set up your division problem. Try to use 2c and 4c cubed. Nothing will fit here. How many 2's fit into 4? 2, and how many c's do I need? Good, 2. 2c squared. Remember, you're multiplying by both. That's what kids forget also. It's just going to give me 4c cubed plus 4c squared. Subtract. 4 minus 2 is 2. Bring down your 5c. What am I trying to cancel now? A 2c, and you always underline the first term. So 2c and 2c squared. So this time, all I need is a c. Multiply times both. And then remember to subtract. Be careful, subtract both. So 2c minus 2c goes away, 5c minus c is 4c. Bring down to negative 3. You try the next number. Okay. What'd you pick? What goes here? 2. So you get 4c plus 2. Negative 3 minus 2 is negative 5. When you write your answer, we're going to put negative 5 over what? The entire 2c plus 1. So your final answer to the problem would have been 2c squared plus c plus 2 minus 5 over 2c plus 1. Does that make sense?
Yeah.
Too much. Okay, of course, now that makes sense, we gotta change it up a little, right? So if you weren't listening, or you quit listening because it was easy, and then tune back in because we're gonna change it a tiny bit. This problem gets a star, it's a little bit different. You'll notice that the problem is 2x minus 3. There's nothing unusual about this. Okay, it's this part that's different. We have an x cubed, an x squared, and a 9. Okay, you have to have one of each, right? A cubed, a squared, and x. The x is missing, okay? In just a second, I'll show you what I mean by that, all right? We'll try to divide. And if you didn't have it, you'll see that your answer, you'll know you messed up if you forgot. So we're going to write it out, and I'll show you why it matters. So 2x minus 3, inside a new radical, we're going to put 8x cubed minus 4x squared. We don't have an x term, so we're going to put plus 0x minus 9. You have to have a placeholder. Write yourself a note if you want. X is missing. So put in 0x. It's important. Okay, let's give it a shot. So we've got 2x and 8x cubed, which is going to mean we need 4x squared. Multiply it by both terms. Giving me 8x cubed, I'm sorry, and 12x squared. I'm going to subtract them. Watch your signs. Negative 12 is going to turn into a plus. Plus 12, I'm sorry, negative 4 plus 12x is 8x squared. Okay, here's where it gets kind of strange. Look what would have happened. What's our next step? Bring down the next term, correct? So right now we have 0x. So go ahead and bring that down. And I'll show you. This is where you'll see why we needed a 0x. Okay? If I put x, I'm going to try to fit 2x into 8x squared. So we need 4x, correct? So there's my plus 4x. Now I'm going to multiply it. 4x and 2x make 8x squared. Watch. What would have happened now? 4x minus 3 is how much? negative 12x. So if this 0x would have been gone, what would I have brought down? A negative 9. Could I put a 12x and a 9 together? No, they weren't like terms. You see why you had to have a place value. If you don't hold that spot, then you can't combine like terms. Okay? So then you end up here with your negative 12x. You're subtracting. This cancels. 0 minus turns to plus, so 12x. Now bring down your negative 9. Two x into 12x, you need 6. Which gives you 12x minus 18. And you're subtracting. Negative 9 plus 18 is 9. So plus 9 over 2x plus 3 is your final answer. Yeah, it's minus 3. Thank you. Okay, next problem. Last one we're going to do. Initially, it doesn't look any more unusual than anything else that we've done. But right off the bat, what do you see that's unique? I have a cubed, a squared, what's missing already? An x. So let's take care of that first. Now for our division, nothing will go here, 3x into 6x cubed. What are we going to need? 2x squared. Remember to multiply by both. You do first, you second. 2x and 3x make 6x cubed. 2x squared and negative 2 make negative 4x squared. Oh, guys, what did I forget? Yeah. I said it, just didn't write it. Sorry. If you forget the placeholder, you'll notice. Okay, when you go down and divide and you can't combine like terms, you realize there's a problem. 3 plus 4 gives you x squared. Bring down your 0x. Okay. The problem here is what? I'm trying to get 3x into x squared. Yeah. Some of you already see it in your head. I'm trying to get from 3 to what's written, a 1, right? It's really not there. I'm trying to say 3 times what number gets me to 1. Okay, if you don't know, make yourself a little think box and think about it. I know that 3 times something gets me to 1. What number is that? Solve for x and figure it out. Divide by 3, x is 1/3. Correct? So if you didn't know, you can find it. So the answer then would be 1/3 x. 1/3 times 3 is 1. There's your x squared. What's 1/3 times negative 2? Negative 2/3. Good. Subtract. 0 plus 2/3 is 2/3 x. What's my next step? Bring down the negative 7. Okay, I'm going to stop right there and see if you can use my last think bubble. Make your new own think bubble. I'm trying to get from 3x to 2/3 x. Either you know it in your head or you don't. If you don't, try to find it. Three times some number is going to get me to 2/3. I got to figure out what number it is. Okay? Think about it like that. I'm at 3 times something needs to land me at 2/3. What works? You put so times 1/3 on this side, times 1/3 on this side, so x is 2/9. 2/9 is what works. Now I need 2/9 times -2, which is -4/9. You might want to use your calculator for this part, but -7 plus 4/9. Even if you got to -59/9, now you still need to know how to write the rest of your answer. Yeah. Go back and look at what you have. Okay, we know when we have a denominator answer, so when we have a remainder, we put the remainder on the end, and this goes in the denominator, correct? So put your remainder over here, 59/9, and where does this go? The 3x minus 2, does it go with the 59 or the 9? Right, the 9. So 3x minus 2. There you go. And that's your answer.